For most people, the word sleep defines relaxation after a long day. However, your body undergoes many changes during the hours when we are unconscious. The human body constantly separates, repairs and revitalizes from getting back the damage of the day and getting ready for the day before. The next time we wake up like a different person, a more vigorous brain is formed. 1. Creating filing in the brain. Humans are very active organisms. Memories are made by doing something, going somewhere and interacting with people. Memories are stored inside the brain. However, as anyone who tries to find a file on a crowded desktop knows, things that are not easily accessible and saved if they cannot be found are of no use. The brain actually repeats the events of the day during sleep, catalogs them and stores them in the brain's long-term memory centers. At the same time, the brain throws unnecessary memories. Keeping important long-term memories is critical to people's ability to work properly. The reason for this is that long-term memory is actually unlimited, which means that these memories will remain for life. Most people can remember certain memories very vividly from childhood, but they feel that they have a harder time remembering exactly what they did 2 days ago. This type of memory prioritization is necessary for the learning and retention of knowledge as well as for the development of skills such as problem solving or mastery of a sport or game. Most of this memory consolidation takes place during sleep, one of the deepest parts of slow-wave sleep, where there is little other brain activity. As the mind goes to REM, rapid eye movement, sleep, the brain then balances critical memories for quick recall. 2. Blood pressure and body temperature decrease. It begins to lower the body temperature about 30 minutes before falling asleep. It does this to the point where we can sleep for hours without going hungry. As a result, heart rate and blood pressure also decrease. Where this may not seem important, the core body temperature drops from about 1.1 degrees Celsius to about 35.6 degrees Celsius, 96 degrees Fahrenheit. It is somewhat superior to hypothermia. Your body also needs less energy, so there is no danger of freezing to fall asleep. When we are about to wake up, blood pressure and heart rate rise rapidly. 3. Paralysis. Have you ever had a nightmare and you couldn't run or scream? While this can be terrible, this phenomenon, known as sleep paralysis, is what prevents us from playing all your real-life dreams, possibly a good thing. Blocking neurotransmitters and receptors in the brain's muscles during REM sleep, where dreams occur, effectively paralyzes you. Sometimes, it can happen for a short time when you fall asleep or wake up. During this time you are completely conscious but you cannot move at all. This is quite terrifying. 4. Stretching. During the day, the spine is pressurized downward due to gravity and the spine is compressed. As a result, the fluid will flow out of your spinal discs and you will actually shrink by 1 centimeter (0.4 inch) by the end of the day. Similarly, when your back is relieved of all this stress, the fluid is allowed to return to the additional joints and stretches additionally 1 centimeter (0.4 inch) to the body. Although this height difference is not so important, the lack of pressure allows children and adolescents to grow asleep. In fact, we can only grow while we sleep. The reason for this is the pressure released from the spine and the growth hormones that are released while lying down and sleeping while sleeping. 5. Sleeping sleep. Although not everyone has to walk through sleepwalking, we can include enough people from the general population, about 30%, in this list. A type of unconsciousness, also called sleepwalking, is technically sleep disturbance, and the brain is in a semi-unconscious state, performing complex tasks such as getting out of bed, going to the kitchen, or even driving. Obviously, this can be very dangerous. However, sleepwalking is especially common in children. Parents, roommates, can often be confused only to return to bed, while the somnambula in question performs strange behaviors such as preparing meals. Although research shows that it may be genetic, scientists still aren't sure people are sleepwalking. Sleepwalking usually happens when the brain is busy processing day memories in slow-wave sleep, which may explain that the sleeper's short-term memory is not very active while in a docile state. In fact, the person in question will have no memories of the previous night's events when they wake up in the morning. 6. Body spasms. As described above, we are often paralyzed while sleeping and this prevents us from performing in our dreams. However, there is a gray area. When the body is not physically asleep and not awake, most people experience what is called a hypnic scum. It is believed that there is a delay between sending the brain to rest the message and receiving the message. It is not fully understood how this reaction occurred. Some scientists suggest that they remained on a primitive reflex that misunderstood from falling asleep by falling from a tree. Others say it is misfiring only because the nerves are closed. Whatever the reason, hypnic events are one of the few reminders of complex processes that occur while sleeping and which we can observe while awake. 7. More energy use. Much of the energy produced while awake, about 80%, is used by various physical activities such as movement, breathing and speech. While sleeping, this energy is obviously not used and the excess energy is directed to the brain. This means that the energy consumption of the brain is higher than when awake at certain sleep steps like REM. This energy is well utilized by completing the awake secretarial tasks, such as creating neural connections and strengthening and removing waste materials. The brain is busy with more urgent and energetic tasks, such as making decisions for other activities throughout the day. However, there is free time to correct the brain during sleep. 8. Weight loss. Did you wake up because you were suddenly thirsty? This is because your body loses 0.5 kilograms, 1 pound, of water into the air in the night environment. Think about it this way: the temperature of the air in your lungs is around 36.7 degrees, 98 F. It is also filled with moisture. Since most people's rooms are much colder than 36.7 degrees, 98 F, you will remove moisture from your body into the air you breathe in sleep while the body is cooling. The weight of lost water is very small, only about 0.02 grams per breath. However, you can add more than 0.5 kilograms, 1 pound, of lost pounds overnight. CO2 has similar but less impact. Everyone knows that you breathe with oxygen, 2 atoms, and carbon dioxide, 3 atoms. When more atoms come out than enter, an extremely small amount of mass disappears each time you listen to your breath. However, when you breathe, each breath has about 1 billion trillion carbon atoms, so about 0.7 kilograms, 1.5 pounds, decreases every night. This happens during the day, but you do more than just replace water and carbon with food and drink. 9. Cleaning. During the awakening hours, toxins and other waste products accumulate throughout the brain and the body's cells. Your brain starts working when the rest of the body is closed while you sleep. Essentially, it opens a valve that allows the cerebrospinal fluid, seen in the picture above, to flow from your spine into your brain, rinse the tissue and remove all toxins. This process is part of a larger cycle known as cellular respiration. Reactions that energize cells with nutrients and maintain the body. Toxins removed at night are leftovers from this process. Although this cleansing is all over the body, it is the most obvious in the brain, the effects of which are the obvious effects of insufficient sleep. This remaining brain wreck is one of the main reasons why you often feel terrible after a long night. 10. Dreams. How can we forget dreams? They are so ordinary but important in life, and yet scientists still understand almost nothing about them. This includes the question, why do we dream? Every night your body is unconscious, your brain symbolizes an imaginary reality that exists only in your mind, but that you think is real. When you wake up, almost all of them disappear from your memory. No matter how strange it sounds, his dreams are considered a reality of life, such as brushing teeth or working. Although the actual need of dreams is unclear, the related activities that occur during REM sleep are understandable and abundant: long-term memory enhancement, washing of toxins into the brain, increasing secretariat work, etc. This makes it even stranger that we know very little about dreams themselves. These questions are nothing new. Speculations about the cause and meaning of dreams are a fascinating element of humanity, at least for tens of thousands of years, dating back to the ancient Greeks and Egyptians. Despite the use of modern technology from MRI scanners to EEG detectors, theories about the origin and purpose of these mysterious experiences will remain, at least for now.